Welcome, everybody. My name is Damon Torgerson, and we are excited to welcome you to EduCraftCon, a free online webinar for educators by educators. This online conference is hosted and co-moderated by ClassTime, and their CEO, Valentine Roost, is here with us today, and myself, Damon Torgerson, CEO of Alludo. Alludo and ClassTime decided to partner in establishing a series of webinar sessions where educators can share their craft with other educators for free. This 45-minute webinar will be recorded and shared with you. You'll receive a link shortly after the event, so don't worry if you can't stay for the entire time or if you have a colleague who couldn't make it. Also, we'd like to make this webinar as engaging as possible. We've got a great speaker today, so we highly encourage you to ask questions anytime in the chat, and we'll try to have them answered during the presentation. At this time, I'm going to turn it over to CEO of ClassTime, Valentine Roost.
Great. Thanks, Damon. I'm also very thrilled to welcome you to EduCraftCon, especially for our current session, The Missing Key to Improving Elementary SPAC Scores with Scott Houston. So Scott is a California-based K-12 educational consultant with teaching expertise in math and science. And in his early career, he taught both middle and high school over an eight-year period before continuing his career as an educational consultant, helping teachers now implement research-based teaching strategies, and most recently also preparing districts for the Common Core and next generation science standards. So without further ado, I'm excited to hand over the word to Scott. Welcome.
Good afternoon, everybody. As Valentine said, my name is Scott Houston. I will be your host for today. And we're going to jump right into it. With only 45 minutes, we want to be able to get as much done as we possibly can. But just so I can see who's here, would you please type your name into the chat, just so I know exactly who we're talking to, and feel free to ask questions at any time as we move through this. So one of the first things I want to be able to do is talk about the 3 keys of elementary SBAC improvement. So many times when teachers are getting back results from the SBAC, all they're seeing is like the specific, my kids aren't doing well in algebra and operations, they're not doing well in the number system, expressions and equations. So what we want to be able to say is get a little bit deeper into why that's happening, because they don't know if it's content, they don't know what's going on in a lot of those cases. So how do we target it just a little bit stronger and a little bit better? So the first key that we're going to be talking about is the one we're going to be working with today, which is the one with the fancy key on top. And it all has to do with the strategic thinking. So many of the questions the kids aren't missing because they don't know the content. They are missing it because they do not understand what the question's asked, or they don't understand the technology behind the question. And so teachers get it back and they're like, I could have sworn my kids knew how to add and subtract fractions, but they didn't do well in the fraction section. I don't know what happened, right? So we really want to be able to like explore that today and get in depth. The other 2 keys that could be talked about are how they're going to be doing on performance task and how to improve upon that. And then the tech that could be used to really help get the kids ready for experiencing that tech above and beyond just say the practice test or the IABs. But that number 1 thing is what we're really going to be focusing on today. So the goals for this particular training are here. I want you to know the types of strategic thinking that the SBAC is demanding from the students, that when you see it, you can recognize it. 2, I want you to be able to really be able to target it when you're looking at an IAB, when you're looking at a release item, or even if you're just kind of walking through the classroom during the SBAC, like you gaze at a question, you're like, oh, I know the kind of strategic thinking that is. I know how to target that. I want people to just be able to do it automatically as if they see an addition problem and know it's addition. Like we want to be able to get it that strong. And then the last piece is to really say, all right, so if that's the kind of thinking I want to engage in, I want to bring that in and I want to have engaging, interactive activities that will help target that. Because if kids can't have fun with it, then they're going to have a hard time learning it. We don't want that. So these would be the 3 goals for the session that we're going to be working with today. So let's go and talk about the CST a little bit. And if you remember the CST a few years back, there were two common stressors, which were content. The kids either knew the content or they didn't. That was a big case of why they missed the question. The vocabulary, if they didn't understand the wording of the question, that would sometimes throw them off. But those were the two main stressors of the CST. The SBAC comes along and they add in two brand new stressors. One is that type of question. Do kids know how to drag and drop? Can they interact with it? What about those checkbox questions? Checkbox questions drop scores by like 30, 40%, depending on how strong the kids are on the content. So, I mean, that's a big one. And then the type of thinking, in this case, we have an example of recognizing operations. How good are the kids at reading a word problem and knowing if it's add, subtract, multiply, divide? Do they know what kind of percentage and how to put that together? Like, how good are they at that particular skill? So when we're looking at how the stressors of the SBAC have changed, the teachers are still a lot of times operating under stressors 1 and 2, where they're really teaching the content, the books going after it, they're doing the vocabulary, everything they used to do on the CST, and they scored much higher. But the types of questions, the tech of the questions are dropping the scores because the kids just aren't ready for them on a regular basis. So that's what we're going to be looking at today, is that type of thinking and how to like target that for our kids. So here's the first activity I'd like you guys to do. So take a look at these 10 types of strategic thinking. And you may be familiar with some of them. You may have seen the language with some of them. But are there any of these types of strategic thinking that you're like, well, what exactly does he mean by that? What types are there? What kinds of things do I want more information on? So that if I were to spend a little more time on one than the other, that might be useful for you. So take about like 30 seconds, kind of look them through. And then as you're doing that, type them in over here, and then I'll be able to see exactly which ones you may want to focus on and take a look at. All right, converting word problems to expressions. Thank you, Melinda. All right, and the comparing. Yeah, that shows up a lot. All right, and +1 for word problems. Okay, oh, I see, that was from you, Damon. Okay. Claims, excellent. All right, so as we move forward, when we put together all the data, we wanted to look at all the test released items, and you'll see question 1, and we broke it down. Type of problem is, it's a word problem. That tended to be about 53% of the test, 3 through like 7th grade. There was like 53% word problems. So kids were struggling a lot of times on those. Then we would see the short answer type in. A lot of times kids would be typing in the answers and they would have the right answer, but because of the way they typed it in, like they added the expression, the whole expression instead of just the answer, and they would miss the question, not because they didn't know math, but because they didn't know how to really navigate like the typing and tech part, right? And then over here, you're going to see the recognizing operations. So it basically said, did kids know to add, subtract, multiply, or divide around double-digit addition within a word problem? So this would break down every single question for you. There is a link at the top that Valentine can put into the chat. And what it'll do is it'll take you right to that document. And if you wanted to look at it and then just get an idea of the kinds of tech, the kinds of thinking, how often they showed up for grade levels 3 through 6, you would get to see all of that. So I just wanted to explain why that was there and how it could be a useful tool for you. All right. So one of the first things that you guys were talking about is you wanted to see something along the lines of like kind of almost like a conditional problem, a comparing problem. So here's an example of one that fits 2 categories: situational analysis with comparing. Okay, So all of this, they have to compare to each other. But what makes this a situational analysis? So the numbers are used in the statement. So you have to use those 4 numbers, and then you have to select all the statements that are true about them. And it's in a checkbox format. So we're seeing kids score like 19% on this question on the IAB. And why is that? Because they're only checking one box. So sometimes it's the tech. But a lot of the times they're looking at just the number here, and they're not looking at the deeper reasoning behind it. So they might see here that the hundreds place is larger in 8361, but because the inequality was true, they checked it, but they didn't look through the whole thing. So a situational analysis question forces kids to really look at it in depth, one at a time. And because it looks so much like a multiple choice problem, a lot of times kids are just choosing it once and then moving on. So this kind of situational analysis question, the kids struggle on a lot. It's usually in a checkbox format, and then we see scores drop. And you'll see a lot of comparing questions that do stuff like this. Comparing questions show up a lot in the checkboxes. Comparing questions show up a lot in the tables. So we're going to see those kinds of things pop up, and they really affect the kids' scores. But when the data comes back on this, it looks like your kids don't know place value. But it was the type of question that got them, not because they didn't know the place value.
Mm-hmm.
So,
Scott, if I may ask here at this point, do you see any difference throughout the grade levels with the recognition of the differences and the question types?
Not necessarily, because as the content grows, the types of questions tend to go right there with it. And so we will see the kids doing as bad at the checkbox questions in 6th grade as they are at 3rd grade. And a lot of times it's because the textbook isn't training them how to handle these kinds of questions. And then if the teachers not seeing it in the textbook, and then they're not being asked to focus on these things, it can be very difficult. That's why you need a platform that really helps you get better with checkbox questions, right? The IABs only have maybe 1 or 2 of these in there, and they only have that same question over and over again. So where can kids go to practice this kind of thing? And this is where you bring in some of that tech. Like, for example, ClassTime would handle this kind of question perfectly because they have the checkbox format, right? So did that answer your question, Valentine? Wonderful. Okay. Now here's a recognizing operations question that, once again, scored less than 20% for most of the kids who were taking it. And it was just a simple multiplication of fractions, not that difficult, but the way the questions were worded, the way the fractions were put into each expression or statement really threw kids off. They couldn't tell which ones were addition, subtraction, multiplication, or division. And so this is something that really will throw them off if they're not exposed to it on a regular basis. Most of the time, kids are asked to read a word problem and find the expression that goes with it. And they're not very good at that either for the most part. But when it's something like this, when it's a reverse word problem, they really have a hard time differentiating between the choices. So in this case, that recognizing operations can really cause problems for a lot of kids if they're not giving explicit practice on how to do that. Right? And then as we move to our last example that we're going to be looking here, once again, comparing was on the list. This is a lot of times how they're going to be doing comparing. They have to look at a statement up on top here, and then they have to do the math on this, and then do the math on every single one of these, and then click every single one of those correctly in order to get the answer. They miss one, the whole question bombs. So if you don't know unit rate, of course you bomb this question, but if you don't understand how to read and understand this kind of comparing question, it throws you off very badly. So a lot of kids will say, but I knew unit rate, but they made one mistake, whole thing goes down. So comparing has all sorts of different looks, but it almost always goes, there's something in the statement, in the question, then they have to look down at the answers, whether it be multiple choice or checkbox, or in this case, a table question. And we're just seeing as soon as they get to that kind of tech and these kinds of questions, the kids are not doing nearly as well as they could be doing. And this is why when teachers get back some of their scores, they feel defeated because they taught unit rate. And their kids probably could have scored 70, 80% on a typical multiple choice question, but now they're scoring 40% because they made one small mistake. So at this time, I would just like to take about another 30 seconds. Any questions so far on taking a look at some of the different kinds of strategic thinking? Because in the next few questions, I'm going to have you take a look at a question and kind of do your own little analysis. So I'll always do like about 30 seconds of thinking time before we head back in. So any kind of questions before we move into your analysis that you're going to be looking at? All right, and as you're writing your questions, if you are, I am then now going to move into our question sharing analysis. So this is something we want teachers to be able to do at every single level. We want you to be able to look at a question and then look at that strategic thinking chart. And this next one I'm going to show you has actually 3 right answers. There's 3 types of strategic thinking buried into this one question. So just kind of look at it, type in what kind you think it is, and then we'll talk a little bit about which ones are there and why, and give yourself a point over on the side if you got it right. Like I said, there's going to be about 3 correct answers on this one. So everyone, take a look, and then you'll notice at the top, these are the 4 questions that teachers want to be asking themselves when they see an IAB question or when they see a test release item. Is first, what's the content? So in this case, we're comparing fractions, right, to whole numbers. So that's our content. Is this computational, conceptual? Is it problem solving? Is it a what and a why? What and a why means they have to give a reason. Is there any place here where we give a reason? If no, then it's not a what and a why kind of question. Are we analyzing a word problem? If not, probably not a problem solving. But do I need to know more than just computational thinking in order to get this question right? In this case, absolutely. This is conceptual, right? Then we get to what's the tech? So what do kids have to do technology-wise to pass this question? So we take a look and we see right here, I've got 5 numbers. I've got 6 boxes. So that freaks some kids out right away because they feel like they can only use each number once. And so as they start filling in the numbers, they're like, I don't know what to do now, right? They don't think they can use the 5 twice. For the ones, I've seen kids just go like, I'll put it as close as I can and do like a 2/3. And it's just because they haven't been trained on this type of question, right? But, so that's the tech. That's the conceptual. This is comparing fractions to whole numbers. But what's the thinking? So if you go back in the training to here, which one of those do you see as being part of that problem? So if you want to kind of open up like this, take a screenshot so you can see this picture compared to what we're doing, that might be a useful thing for you as you are looking at the question itself. So any guesses from anybody? And then, Valentine, Damon, you guys want to play, take a look at it. What do you guys think? And then anyone in the chat, just kind of throw out your answer. What kind of strategic thinking do you see being asked for here? Comparative, absolutely. So since we're comparing whole numbers, visual analysis. All right, so we have to be able to look at the boxes, absolutely, and be able to figure that out. Then algebraic reasoning, because we have missing numbers that we're trying to put in there, that's going to be something that we've got to make right. And then the other one that's going to be in here is going to be the conditional. Like, there are tons of answers that will make this true. 2/2, 3/3, 4/4, tons of answers here, tons of answers here. but I have to meet each condition in order to get this question right, and I have to do it for every single one of these. If I make a mistake in one of them, it's all done. If I don't know how to use this delete button, tech-wise, if I make a mistake, I may not know how to fix it. All of these things comes into play with this kind of question. But absolutely, we got comparative thinking, we got algebraic thinking, and we've got conditional thinking in this particular question. So great job if you used any one of those three, great. Now, visual analysis is more like, do you need the visual in order to answer this question? So I'm just going to go back a little bit to address the visual analysis question. And visual analysis looks a little bit something like this. You are given some kind of picture, chart, graph that is absolutely essential to the question itself. Like, I can't answer this question without that visual there. So this is a really good example of a visual analysis question. Kids as a whole, because it was typed in their answer, we saw lots of mistakes with this kind of thing. When it was a multiple choice kind of question, kids did far better in visual analysis with this kind of question than they did when they had to type it in. We saw drops of like 15 to 20% between this kind of thing. So just wanted to kind of get on how visual analysis was just a little bit different here. All right, so once we've determined what kind of question it is, then what kind of activities do we do to target that question? Something that engages kids, makes kids think that way. What can increase algebraic thinking? What can increase conditional thinking? What can increase in comparative thinking that's fun for the kids? So here's an activity that does that called the elimination computation. So basically, let's take a look first at the conditions of the question. So everyone, take about 10 seconds, read the directions, and see if you can identify every condition that you would need in order to answer this correctly. So take about 15 seconds and just think it through. All right, so first off, condition number one, I've got these 9 numbers, and I have to use each of them. Condition 1. Condition 2, you can only use each of the numbers above once. And then condition 3, I have to make all of these things true. Now, there are several right answers. But what I want you guys to do is I don't want you necessarily to solve this. I mean, if you want to solve it at home, absolutely. But what I want you to do is I want you to kind of look at this and tell me, where's your starting point? Where's your metacognition on this? Because we want to help kids look at something like this and be able to think their way through it. So what are the first things that you would do? How would you target this question? So take about 30 seconds, type in your answer over on the side. Which one would you start with? Or how would you start this process? And I just kind of want to know what you're thinking. And Valentine, Damon, while they're doing that, I'd like to have a conversation about this. What's your thinking? Where do you think this would go?
You've almost got me stumped.
It's difficult. Yeah.
I would do process of elimination. I would just start plugging numbers, which would not probably be a very good strategy.
Okay, so for you, it would be just like start making things that are true. But yeah, where would you start making the things that are true? Where would be your first target?
Probably the fractions, because I'm going to eliminate, because there's only certain fractions that can combine into that, or certain numbers that can combine into that.
So this would only be 1, 3, 2, 6, or 3, 9. So there's a very limited amount of numbers that would fit in that particular fraction. That makes good sense. I see Melinda over there. She was saying that she would target this one first, right? And so a lot of people look at this, especially the younger kids, they know subtraction. And they're like, I would target that one first because there's so many correct answers, right? And so all of these could have different endpoints, but what you want the kids to do is say, when I have this many different endpoints, how do I start thinking around it in such a way that I can do it the fastest? Because if I spend too much time on an SBAC question, I start getting frustrated. And if I've never seen anything like this before, then once again, the type of thinking and the tech get me. But if I've been doing this kind of thing in class, I have a metacognitive process for jumping into this, right? And that's one of my favorite things to do too, Damon, is I like to go after that 1/3. There's only so many numbers that will fit in there. And so then I might start doing a little bit of guess and check. I also like going after that 4 down there on the bottom, because you see how there's a red, a blue, and a green? That indicates different numbers. So that's going to be a double digit over a single digit.
I was wondering.
Yeah. So I'd go like 2, 4, 6, right, for that one. And then as soon as I do 2, 4, 6, that leaves just 1, 3 for that top one. So now I've used 1, 3, 2, 4, and 6. And now I'm looking over here on the other side, and there's so many options for that greater than 1/8. I mean, there's tons of options for that.
Right.
I'm saving that to the end because there's so many ways I can get there. And then with this one, the 3, now if I've already used 1, 3, 2, 4, and 6, like, do I have anything left that will get me to that 3? Right? I have 8 and I have 5.
There you go.
So that would get me to where I'm going. But kids don't naturally think this way without prompting and activities that bring us there. And so this is what I mean by teachers need to be able to not only recognize questions, but they need to be able to create activities that help generate algebraic thinking, conditional thinking, comparative thinking, right? The book doesn't necessarily do things like this. The book tends to really focus on their computation and their word problems. So when kids get things like that last problem we saw, they struggle because they've never seen anything quite like it. All right. So, and thank you for all your comments over on the side. Love to see everything that's going on over there. Thank you for the participation. Now we look at something like this, okay? And once again, I'm going to take us through the process. Content. We're comparing fractions once again, right? Definitely conceptual. The tech, check boxes. We can see the check boxes are happening there, right? And then we go to the thinking. So if you go back to our 10 types of thinking, what do you see in this one? So once again, take about 15, 30 seconds over on the side, go back to it, type in 1, because there's about 2 kinds of thinking that you're really going to see in this one. So Valentin, do me a favor, just kind of look at this question, describe it for me. What do you see happening in this question?
Yeah, so I'm looking at the answer. I definitely see like visuals, right? Some sort of visual analysis that I have to do. I look at the answers. So I need to understand the different operations that are there and what they mean. So recognizing operations, I guess.
Okay. And so when it's recognizing operations, it's like, are you looking at the problem and then saying, I have to figure out what the operation is in order to solve it? Like, do you have a doubt as to what kind of operation you're going to use? Like when you see an equal sign, you probably know what that means. But are you looking at the problem itself and having to figure out what kind of operation to use? That makes something recognizing operations. But the visual analysis, absolutely. You cannot solve this question without doing this. And then I see that over on the side, Melinda was comparing, absolutely.
Comparing, yeah.
Converting visuals to expressions. In this particular case, it's not exactly doing that, and here's why. It's because these down here are, they're not asking you necessarily, well, I guess, yeah, no, I think you're right. Converting visuals to expressions would fit this, because they're saying, does this match this? This expression matching that visual? So yes, absolutely. So when you look at something like this, if I were to add this one, I would like you guys to tell me if you think you would check box the one I'm throwing in there. So they've given us 4 situations. The 2 that are correct are already check boxed. Okay. I'm going to throw a 5th one in there. So I would like everyone kind of playing at home. Tell me, would you check box what I'm about to say? If so, type in a yes. And then Damon and Valentin, just kind of throw in your answer with a yes or a no. Okay. So I know, I love playing with you guys. I know. Here we go. 1/3 equals 3/18. 1/3 equals 3/18. Would you guys put a check on that?
No.
Yeah, no.
Okay. How about this one? 2/6 equals 4/12. Would you put a check mark on that one?
Yes.
Why?
Well, partially because it's already there. But
Dang it. 3/6 equals 5/10. I was like playing in my head. 3/6 equals 5/10.
3/6 equals 5/10. So yes, it does.
Would you put a check mark on it?
Not it. If my understanding is correct in that I have to that I'm comparing the models to the fractions, then no, I wouldn't.
Aha, exactly. But so many kids on this type of question will miss this because there'll be a true statement down on the bottom.
Yeah.
But because it says select all the statements that can be supported using Anna's fraction models. So you did not fall into the trap. Excellent.
Oh, so, I probably would have if I was a kid. I probably would have fallen into it for sure.
Right? And so many kids do.
Yeah, super hard.
Will do that kind of thing, right? So you're like, okay, great. So now that I have this kind of thinking and it's visual analysis, it's comparative, what do I do about it? So in this particular place, there is a website that actually comes from Math Playground where you can manipulate 5 different fraction bars all the way up to 1/20th. And you can create all these different kinds of things that they can compare with one another. You can create visual analysis questions super fast, and you can have an unlimited amount of them. And you just keep asking questions kind of like I did. Does this model support this question that I'm asking? Can you analyze what I am saying here? And so if you guys are interested in looking at this particular website, you just go right there and you can see that you can like change. The colors are going to be purple, blue, green, orange, yellow. They're going to be very clear for the kids to be able to use and manipulate. And you could use this for equivalent fractions, adding fractions, dividing fractions, so many different things that you could do that helps target the kinds of thinking that you see in this question, right? But once again, the books don't necessarily do it in this way. Most of the time, they'll ask kids to say, what is this fraction? So a lot of kids will just type in 1/6. Like that's the kind of thing they'll do. But for a deeper analysis that says, does this expression match this model? Prove it, yes or no. Most of the time, our books are not doing things like that. And this is why kids are missing the questions that they're missing, right?
That's a tough question.
It is, right? And these are typically the kinds of questions that are just not the things that the kids are ready for. But if teachers are getting them ready for these kinds of things and they're doing it in conjunction with what the book's doing, you'll see lots of kinds of that thinking improvement that the kids so desperately need. But most of the time, educators just like, how do we do this? We're not sure. What's our direction? And so this kind of helps see that. If they analyze the questions, recognize the kind of strategic thinking, and then have the tools they need to get there, this is how SBAC scores improve. But most of the time, this kind of conversation isn't going on. So this is what I call the most infamous 5th grade question ever. Take a look. I'm going to give you guys like 45 seconds. Just kind of read through it really quick. And then give me just your impressions on what you notice happening here. And we're going to talk about the kind of strategic thinking that's going on. So I'm going to be quiet for 45 seconds. Everyone, just take a look. See what you think is going on here. All right. So, Damon, just describe what you're seeing to me.
Fifth grade is hard.
That's why I'm not asking you to solve it. Just tell me.
So there's multiple things going on from my perspective. So one, I've got some constraints. I can only order full pizzas. So I can either order cheese or pepperoni, but I can't order half of a pizza. And the kids want portions that add up to more or to less than those whole pizzas. And then there's the kids that want specific pizzas in there. So those are kind of the constraints that I'm seeing in the problem.
And you're using the word constraints, which is a great word. The word we tended to use in the strategic thinking were the conditions.
Right. So conditions.
This particular one has like 8 conditions in order to solve it. You've got to know that Abe wants half, Becca wants 2/3, Cam wants 2/4. You can only give the minimum number. Like that's the most constraining thing down on the bottom. Otherwise, you could put any number to meet the original question.
Right. Order 100 pieces.
Exactly, right? And you'd be right if it wasn't for that last condition.
Right.
So many kids miss this kind of thing is they don't know how to navigate or understand all of the information being thrown at them. This is like paintballs of information being thrown their way, you know? And yes, Melinda, kids don't think about the leftovers. They want the exact number, right? And something like this finds it really hard to get to that exact number. It's so big, it's so convoluted. And conditional thinking is one of the hardest kinds of thinking. And it's one of the rarest kinds that you see in the textbooks. But it's fairly common amongst the SBAC. We'll see these in about 2 or 3 questions per 30 questions that they're investigating, that they're being put forth in. And these tend to be some of the lowest ones. And then this would be an activity that we would use to target it, something along these lines. Now, there's tons of ways we can target it. There's great websites that will actually target it. But something like this, where if you want to engage the kids, you bring some cards out, you throw like 3 numbers down. Like here, we've got the numbers 3, 8, and 5, right? So now the kids have to look at conditions 1, 2, 3, 4, and 5, and they'll have their deck of playing cards out in front of them, so they're manipulating it. And they have to come up with a 3-number combination that meets all of those conditions. Due to our time, I'm not going to actually have you guys kind of interact or play with this particular one. This is I know you guys are like, oh my God, I didn't know we'd have to make this hard.
I wasn't even listening anymore, trying to solve it ahead of time.
But you can see here, there's going to be 6 conditions. It looks like 5, but there's actually 6 because the 6 conditions is the 3, the 8, and the 5 itself. The very first few cards has the comparison thing going with this. So you are going to see all sorts of language being thrown in here, along with the conditional kinds of thinking that's being asked to be put forth. And then this last one, because someone mentioned not only conditional thinking, someone mentioned they wanted to see claims. So here's an example of a claims question, right? And you want to use some very specific vocabulary around claims. So here we have that Julia needs to make a box in the shape of a rectangular prism with a height of 3 inches and a volume of 243 cubic inches. Julia claims that the width and the length need to be exactly the same in order for this to work. So now, if you look at the language for part A, what would support Julia's claim? And then part B is what would not support. You're going to see language like support, dispute, support, refute. You're going to be seeing that kind of thing. And so people are going to be making claims that you've got to either say, I accept this claim and here's my reasons why, or I deny this claim and here's my reasons why. And then they have to type in their proof or their disproof of the answer. And there's so many ways they target claims, so many ways they do these kinds of questions. You'll see it a lot with the step 1, step 2, step 3, step 4. Where does the student make their mistake, their first mistake? Can you identify it? That's a type of claims question because that's a student saying, I believe this, 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 and this, and you have to either support or dispute their mistake, right?
Mm-hmm.
So this kind of question, this is a 6th grade question, by the way, it's a volume question, that so many kids miss because they just type in the part A part because that's the only part they understand, and they don't understand the part B. Like they don't even know necessarily what it's asking for, how to figure it out, because they only see this as only being one answer, right? So things like this cause some serious problems moving forward. And it's not because they don't know volume. Most of the time, kids can grab a box, measure all the sides, and answer questions about volume. But because it's a claims question, the way it's introduced, the kids miss this question, and then it looks like they can't do volume. Once again, it just doesn't make a whole lot of sense, right? And then here's the activity that I'm like demonstrating today around claims. So if you look in the middle, you'll see a claim. Whenever you multiply 2 odd numbers together, the product will be an odd number. Now, what you're going to do in this kind of question is you're going to say, all right, does 3 times 5 support that claim? If so, we turn it green. Does it refute or dispute the claim? If so, we turn it red. Or does it have nothing to do with the claim? In that case, we turn those like yellow, okay? So with 3 times 5, what color would you guys turn that? So Valentine, Damon, what would you color 3 times 5?
That would be green.
Green. 3 times 5 is 15. Perfectly fits the claim. Damon, what about 21 divided by 7? How would you target that?
Whenever I multiply 2 odd numbers, the product must be 21. I would be green as well.
In this particular case, because it says whenever you multiply 2 odd numbers together, we would go ahead, we would turn that one yellow, because it's still right in the sense that it's the basic operation turned around, but because it's specifically saying multiply, we turn it yellow because it doesn't support or refute.
I see.
Does that make sense?
It got me too, Damon. I was going to say green.
I mean, the teachers could argue, yes, it's the opposite, and you could say it still proves the rule, because 7 times 3, it's 21. But because we threw it in the division and we were looking at specifically at the claim, we would give it yellow. So when you go through all of these, you would find that there's quite a few green, quite a few yellow, but there's not a single red, right? And if that's the case, you move here. So did the table have any evidence to dispute the claim? In this case, nothing. Nothing turned red, nothing to dispute it. Can you think of any evidence to dispute the claim? So now kids are going to do their own kind of freestyling. Can they come up with anything that will target this claim? And so this is a place where they would discuss it. And if they can't come up with anything at all, then this would be considered a mathematical rule. If, however, you dispute it just once, it's not a rule. In math, in order to be a rule, it must be right every single time, right? So this is an example of a claim activity to go along with a claim type of question. And there's so much more that could be going with this, but we really just wanted to emphasize in today's training that you could be able to identify the kind of thinking and that you would have ideas on how you could strategically target it, have some engagement with the class as you did it. So those are some of the things we really wanted to target in today's training. And then the very last slide, I use ClassTime a lot in order to target all these different kinds of tech types and to create some of these strategic thinking questions that I could have. Because I can create tables, check boxes, I can use visual analysis, I can do almost all of these using the ClassTime setting. So any questions with the whole minute I got left?
I mean, while the audience maybe is thinking of questions, in terms of, a teacher who understands now the deeper strategic thinking, the challenges, what are the, small first steps I could take as a teacher to improve on this?
The first thing is just look at these release items and just kind of look at the types of thinking and just get familiar with them. Like being able to just recognize them is the very first step. Because if you don't recognize them, you can't teach with them, right? A lot of times teachers will say, well, aren't we teaching to the test? Absolutely not. We're teaching them to think in a certain way. You're analyzing a situation, life skill, right? You're looking at a picture or a chart, life skill. You got to be able to visualize and understand what's going on with it, right? You've got to understand claims and be able to make claims and support your claims. So all of those things. And with Melinda, with the reading items analysis that you've got going on there, Most of those tend to be straight off of the SBAC standards. There's a document that says these are the kinds of questions you're going to ask, and almost all of them are pretty straightforward in terms of like, what's the author say? They don't do as much playing around with the types of thinking that math does. They do much more like very specific types of strategic around the reading comprehension standards. And so it's a little bit different. That's why I'm talking math, is because it's so much more complicated than the English ones. But please, you can email me at scotthouston@educators.coop, and I'll just type this in here for anyone who would like to contact me. We also go to schools and do trainings like this with the teachers. We spend 2 days, we do some individual, we go into the classroom, model this with the kids. So we do all of these different kinds of things Educators Cooperative does with kids in the schools.
And one quick question follow-up for you, Scott. Are you active on Twitter? Do you want to share your Twitter handle with folks that might want to engage you?
Actually, no, I'm not really active.
Okay. Sorry, I didn't mean to put you on the spot.
I have one, but I don't even think I know what it is off the top of my head.
Okay, no worries, no worries.
Anything else?
Well, the last thing I'll say is thank you very much, Scott. I really appreciate the time, and also to the people that participate in the chat. Like, those were really good questions, and this was
absolutely
certainly challenging for me. And I got an engineering degree, so I'm glad I made it out before they had these questions in the 6th grade. I'll tell you that.
Thank you guys for playing along. I work so much better when I have like a crowd to play with, so I appreciate it.
So thank you everyone for coming to the presentation and participating. As we mentioned in the beginning, this is going to be recorded, so you'll be getting that invitation for the recording. As well, we've got a short survey. It takes about 2 minutes, and it's just really to help us improve the next webinar. So your feedback is critically important. I thank you in advance for filling that out. Thank you for participating in EduCraftCon today. And Valentine, is there anything you'd like to wrap up with?
No, just thanks a lot, everyone, again. And also, Scott, thanks so much for introducing us in depth to the complexities of this. As someone who has seen Scott in the classroom before, I have a much deeper appreciation now as well. So thanks a lot.
Hey, no problem. And this was not in depth. This was the surface.
Yeah, I can imagine. Thanks.
All right.
Thank you very much, Scott.
Everyone.
Thanks everyone for participating today.
Bye-bye, guys. Thank you.